All right. So today we're going to be talking about section 1.5, which is solving compound and absolute value inequalities. So the first thing that we need to do is actually determine what a compound inequality is. We're going to talk about solving these and compound inequalities. We're going to talk about solving or compound inequalities. And of course, solving absolute value inequalities, and then a couple of real world problems with these. Okay, so what is a compound inequality? Well, let's think about it this way. Let's say that you have some x is less than or equal to 5. And let's say that that x also is greater than -6. So let's think about this. If you have a number line, right, and I'm actually going to make two number lines here. For this first number line, we're saying that x is less than 5. So let's say this is 5, and it's less than or equal to 5. And one of the tricks to know how to create these arrows for these is the direction that the less than or equal to value is pointing is the way that you go. So for example, if as long as your variable's on the left, this will be pointing in this direction, right? So we got less than or equal to, so we're going to actually have a shade in right on there, right? Less than or equal to. And then of course, x is also greater than -6. So for example, and it's strictly greater than here, so this is going to be completely open. So -6, and then we're strictly greater than. So the first inequality says that I'm less than -5. The next inequality says I'm greater than -6. Well, a compound inequality puts both of these things together. Okay, so I'm greater than -6, but I'm less than 5. And that would look something like this. So once again, 0. In other words, I'm less than or equal to 5 is at the top, but I am going to be greater than 6. If we put these two together, we see that that is the shaded region here. So for example, we could see that -2 exists in between -6 and 5, but for example, 6 does not. Right? 6 does not exist. Think about it like this. Even though 6 is greater than -6, right? It's greater than -6, but it's bigger than 5, so it would not exist in this compound inequality. Remember, it's compounded because we have two restraints here. Rather than just one, we have two, So that's why we call it a compound inequality. Okay, what if instead we had x is actually greater than or equal to 5, and let's say that x is less than -6. The first compound inequality was called an and compound inequality. This one is an or, and I'm going to explain why. So, okay, back to looking at our number line. In the first one, we've got x is bigger than 5. So basically, once again, greater than or equal to, we're going to have 5, and then it's going to be in this direction. Then we're saying, and we'll put this together, or x is less than -6. So hole right here, -6 going down in this direction. Okay, so with this, basically, if I put these together, and I'll make it look like this, x is less than -6, or x is greater than or equal to 5, then that combined together would look something like this. It's not going to be perfect, but you get that. You're going to get the idea. So we'll start -6, 5 in this direction. Now, what does that mean? That means that let's take the number, for example, let's take the number -1. Okay, -1 does not exist in this compound inequality. Right? It's not inside of that range because it's neither less than -6 and it's not bigger than 5. However, 8 does exist. It doesn't exist in this piece, but it does exist in this piece. So it's either or. It's either you use this one or you use that one. So once again, still two constraints. Only in this case, now we're thinking, okay, well, either I'm going to be less than -6 or I'm going to be bigger than 5. So that's the difference between the and compound inequalities and the or compound inequalities. All right, solving and compound inequalities. So the first thing is let's take this problem. So let's say we have 9 is less than or equal to 3x minus 6 less than or equal to 51. Okay, we want to solve this. So the way you do that is you break it up into two pieces. The first piece is going to be just this down here, and then the second piece is going to be this part up here. So how we do that, let me use a different color here. We're going to have 9 less than or equal to 3x minus 6, okay? And we're also going to have 3x minus 6 less than 51. And you could, you can change this around if you want to, but I think it's going to be easier this way. So I'm going to add 6 to both sides. When I do that, then you're going to have 15 less than or equal to 3x. And then here we got 3x less than or equal to 45. We divide both sides by 3 here, and we end up with x is bigger than 5, or we can say 5 is less than x, less than or equal to x. Divide by 3 here, you end up with x is less than or equal to 15. So if we put them back together, we can see that x exists between 5 and 15. Now, a way we can check this is by picking a value that's supposedly in there. So in between here and here is definitely, one of the values is 10. In between 5 and 15 is a value is 10. So let's see if it checks out. So we would then have 9 is greater than or equal to 3 times 10 minus 6 is then equal to 51. So you end up with 9 is greater than or equal to 30 minus 6 greater than 51. 30 minus 6 is 24 and 51. So it does check out. 9 is definitely less than 24, but 24 is less than 51. So it checks out. What's another way we could have done this problem? Now be careful when you do it like this if you're going to do this method. But what I'm going to do is basically simultaneously deal with both inequalities. So if I'm going to add 6, I'm going to add 6 here, and I'm going to add 6 here. Okay, so then that gives me 15 on the left, far left. I'm left with just 3x in the middle, and then 45 on the far right. Then I would divide everything by 3. So I'm going to divide by 3, divide by 3, divide by 3. So you end up with 5 less than or equal to x less than or equal to 15. So that's another way to do it. Just be careful when you do stuff like that, particularly if you end up having to divide by a negative, because if you have to divide by a negative, then all the signs flip. So be careful with that. It's doable, but just be careful. Okay, so the next problem we have is 5 is less than or equal to negative 2x minus 2 is less than or equal to 15. So the way we're going to do this, and notice your bigger number always is going to be, on the far right. If it's, in this less than way, if it was greater than, then obviously the big one would be on this side. Now, what we need to do is, of course, we could break it up into two inequalities and solve. But what I'm going to do is kind of use a shortcut. So I'm going to add 2 to all sides, basically, which gives me 7 less than or equal to negative 2x, which is less than or equal to 17. Now I'm going to divide everything by -2. Now remember from the last video, what happens when we divide by -2? The signs flip, right? And we talked about why that is. So 7 divided by -2, that's going to be -3.5. So the sign now flips. This is just x, sign flips, and you're going to have -8.5, which makes sense. If it was the other way around, 8.5 is not bigger than 3.5. All right, I'm sorry, -8.5 is not bigger than -3.5. All right, so let's check and see if this is correct. Well, one of the answers that's in here, and let me go ahead and graph it. So if I were to graph this, okay, so one of the answers in here actually is going to be -4, right? -4 is going to be really close, be inside here. So let's see and check and see if this actually works. So if I've got 5 less than or equal to -2 times -4 plus 2 less than or equal to 15. -2 times -4 is +8 plus 2. And then, of course, we have our parameters here. 8 plus 2 gives us 10. And of course, this satisfies our parameter. 5 is definitely less than 10, and 10 is less than 15. So that said, we can see that it checks out. All right, so solving compound OR inequalities. Okay, so for example, we could have that y minus 3 is less than 12, or y plus 3 is greater than or equal to 15. And I meant less than or equal to over here. So what can we do with this problem? Well, just solve them separately, basically. If we have, we could add 3 to both sides, right? And that gives us y is less than or equal to 15. Or we could have subtract 3 from both sides, and we end up with y is greater than or equal to 12. Now, this is something curious. Whereas before it seemed like we have an OR problem, now let's think about what's happening here. Y is less than 15, less than or equal to 15. Y is greater than equal to 12. Well, for this to be the case, then we can see that for this piece right here, y's got to be bigger than 12. So it's got to be 12 or bigger than 12. And then for this piece right here, y has to be less than 15. So actually, it's an AND problem. In other words, we can say that y is between 12 and 15. Now, how can we check to see if this is correct? Let's first check the inside. So on the inside, we can check, say, problem 13. Okay, so if I have 13, let's see, we got 13 minus 3 less than or equal to 12, which gives us 10 less than or equal to 12. Of course, this checks out, right? The other one we want to check is if I had 13 plus 3 greater than or equal to 15, which is true because this is 16 is greater than or equal to 15. So this checks out as well. What if we were outside of this? Well, if I had 0, then I have 0 minus 3 is less than or equal to 12. This checks out because 3 is less than or equal to, -3 is less than or equal to 12. That works. But what if I have -3 plus 3 greater than or equal to 15? Well, this actually becomes 0, and this is incorrect. Therefore, this -3 does not work for both. So we can conclude the fact that this indeed is actually what we want. Y has to be between 12 and 15. Okay, let's do one more OR problem. And I know it may seem confusing, but the biggest thing is this: just remember what everything means. Take your time, make sure that things make sense, and most importantly, check your answers. So let's say we have 2j greater than 2, and let's say that negative 2j is greater than 0. So we've got 2j is greater than 2 or negative 2j is greater than 0. So how do we do this? Well, first, just divide 2 on both sides. So you end up with j has to be greater than 1. Or remember when we divide by a negative, and remember 0 divided by 2 is just 0, we have to flip the signs. So either j has to be bigger than 1 or j has to be smaller than negative 2. So here's our number line. So we've got 1 and we've got negative 2. For 1, it's going to be bigger, so it's going to be kind of going in this way. And it's a hole here because it's strictly greater than. And then there's going to be a hole here, and it's going to be strictly less than. Now, how can we check it? Let's pick the point negative 1 and just make sure that it does not work. So that's how we're going to check it. We're going to pick this point and make sure it doesn't work. So we put negative 1 in there. We end up with negative 1 is greater than 1. We know that's false, right? And if we do this one, negative 1 is less than negative 2. Well, that's false too. So that doesn't work out. If we wanted to pick a number just to check to make sure that it works out, obviously, if you pick negative 3, that wouldn't work for j is greater than 1, but that's okay. It can work for the other one. Remember the last problem we found out it was an and problem, not an or problem. With an and problem, both conditions have to be satisfied. With an or problem, only one has to be satisfied. So negative 3 in this case would satisfy this problem. All right, solving absolute value inequalities. So what if I told you the absolute value of some number is greater than 3? Well, let's think about this. If the absolute value is greater than 3, if we look at a number line, look at 0. Remember, absolute value is the distance between a number and 0, right? So if the absolute value is greater than 3, that means that whatever number I pick has to be 3 away from 0 in both the positive and negative direction. So what we can think about, if the absolute value is greater than 3, then that means either it has to exist over here, in other words, it's got to be bigger than 3, or it's got to be smaller. The actual number has to be smaller than negative 3. Why? Because the absolute value, the distance between 0 and whatever number we're dealing with, has to be greater than 3. Now, it can't be 3 itself, so we should put some holes here. But other than that, it has to be greater than 3. The distance between 0 and the number is greater than 3. The distance between 0 and the number in the negative direction has to be greater than 3. Now, here's the way we think about it in terms of just algebraically. We can say, okay, when you have something like this, you have two cases. The first case is you just drop the absolute value. So you end up with x is greater than 3. Okay. But the second case is where you have x is less than negative 3. Notice, remember when we had absolute values, we always had two cases. We had the first case where the right-hand side was positive, and the next case where the right-hand side was negative. Well, we have the same thing here where we have a positive 3 and a negative 3. But the only thing you have to notice is that when you deal with the negative piece, you have to flip the sign. Okay, so this is actually an or problem, right? We go from x has got to be greater than negative 3 or x is less than negative 3. Remember, when you deal with the negative case, you flip the sign. All right, what about if the absolute value of x is less than or equal to 3? Well, let's see what that would be. All right, first case is absolute value or x is less than or equal to 3. Second case is x is greater than or equal to -3. Okay, so in this case, we have, if we're looking at a number line here, we've got 3, we've got -3. Let's figure out which direction we're supposed to go in. X has got to be bigger than -3, so greater than or equal to, so and it's going to go in this direction. And we've got x has got to be smaller than or equal to -3 or +3 rather. And so it's a tongue twister. So we can see that this is actually an and problem, right? Because we can see that x is going to be between 3 and -3. Okay. So, just be mindful of that. Just remember the cases. One we have to do when it's positive, when it's negative. Let's do some test points. Let's look at the absolute value of 2, for instance. Well, is the absolute value of 2 less than or equal to 3? Well, the absolute value of 2 is either 2 in one case, or the absolute value of 2 is just 2, right? So 3 is 2 less than or equal to 3? Yeah, it is. Is 2 greater than or equal to -3? Yes, it is. Right? So remember, our two cases here, this is just comes from straight from up here up at the top, right? Our two cases are both satisfied. 2 is less than or equal to 3. 2 is also greater than or equal to -3. All right, so we got this problem. It says that the absolute value of x plus 2 is less than or equal to -4. Now, I know the first thing that you want to do is, okay, well, we got x plus 2 is less than or equal to -4, and then we got x plus 2 is greater than or equal to 4, and then you want to solve it like this, right? And then you have x is less than or equal to -6, x is greater than or equal to 2, and then we want to see if this thing works out, right? We've got it's less than -6, so it looks like we have an OR problem here where you got 2, you got -6, and it goes like this, and it goes like this. And so let's pick a test point and see if it works. So let's say 3. Okay. Say we pick the point 3. Well, let's see. If I pick the point 3, then I get 3 plus 2, or the absolute value of 3 plus 2 is less than or equal to -4, which then gives me absolute value of 5 is less than or equal to -4, which then gives me that 5 is less than or equal to -4. Now this is definitely not true. What happened? We did everything correctly. Well, this was actually a trick question. And I'm going to give you a minute. I want to see if you can figure out, why is this a trick question? Okay, here's the reason why it's a trick question. It's a trick question because remember when we talked about absolute value in section 1.3, and we said, hey, you can't have the absolute value of a negative number? Why? Because the absolute value is a what? Distance. You cannot have a negative distance. So this whole statement from the jump absolutely makes no sense. So be careful. Remember to think about the definitions of what things actually mean. Don't just start using a bunch of algorithms. All right, let's deal with a problem that's not false. We got the absolute value of 4x minus 3 greater than or equal to 5. All right, let's do this problem real quick. So we have our two cases. 4x minus 3 is greater than or equal to 5. And our second case, and I'm not going to actually check this one, I just want to get through it real quick, is less than or equal to -5. All right, our two cases. Case 1, we're going to add 3 to both sides. You end up with 4x greater than 8. And then you divide both sides by 4, so x is greater than or equal to 2. Then on this one, we're going to add 3 rather to both sides. You end it with 4x is less than or equal to -2, and then you get x is less than or equal to -1/2. Notice I didn't have to actually flip anything from here to here because I didn't divide by a negative. I divided by a positive number, which was 4. All right, so I said I wouldn't check it, but I can't not check it. So x is going to be less than -1/2. I just want to check to see if -1 checks out. So when you have 4 times -1 minus 3, absolute value of that should be greater than or equal to 5. So let's see if it works. So we got -4, that's going to be -4, or 4 times -1 is -4, minus 3, absolute value of that greater than 5, which is absolute value of 7. Greater than 5, absolute value of 7 is 7, is greater than 5. This definitely checks out. So, all right, so let's check one that's greater than 2. Let's see if we can find a problem that is greater than 2. All right, 3 is greater than 2, so we can check 3. So we have 4 times 3 minus 3 greater than equal to 5. So we got the absolute value of 4 times 3 minus 3 is greater than 5. Then we get the absolute value of 12 minus 3 greater than 5. 12 minus 3 is the absolute value of 9 is greater than 5. And of course, we know this is correct. 9 is indeed greater than or equal to 5. Is much bigger than 5. Okay, so here's our real world problem. The average monthly revenue for Byron's bookstore is $5,000 per month. The revenue varies by about $500 per month. What is the range of monthly revenue? Now, just by looking at this problem, you can tell that if my average is 5,000 and I might make 500 more or I might make 500 less, you can kind of already estimate. You're like, okay, well, I can imagine that the range is going to be between $4,500 and $5,500. Okay, but let's use math to kind of express this issue that's going on. So let's think about it this way. What we're saying is let's think about this $5,000 as being kind of like a what would I say it? Kind of like an anchor point. All right, we know we could do 500 above, or we could do 500 below. Now, that kind of seems to me like an absolute value. My absolute value could be, I could be more than 5K. I could be less than 5K. So here's how I'm going to set it up. Whatever the distance between my anchor point and my actual revenue for that month has got to be less than $500 or equal to $500. Okay, so let me repeat that. So basically, the distance between, let's say this is my revenue, and I'm going to use R for revenue. My revenue that month, the distance between that has to be less than $500, right? The absolute value of that, whether it's on this side or whether it's on this side. Now, when we calculate distance, if you remember back in geometry, whenever we calculate distance, we're going to be subtracting something from something. So what I can say is that $5,000 minus whatever my actual revenue is has got to be, absolutely has to be less than or equal to $500. Now, you could have thought about it in this way. You could have said, my revenue minus $5,000 has got to be less than or equal to 500. I'm going to solve both and show that they're both indeed the same thing. So let's deal with this one first. So we got $5,000 minus whatever the revenue is. We've got two cases. Case one, we got $5,000 minus R is less than or equal to 500. And then case two, we've got 5,000 minus R is greater than or equal to 500, negative 500, right? So those are our two cases. So with case one, we got negative R less than or equal to, and then we're going to subtract $5,000 from both sides. So minus 5K minus 5K. 500 minus 5,000 is negative $4,500. And if we divide by -1 or multiply by -1, we change the sign, don't forget. So R has to be greater than $4,500. Now, with the other side, we can, once again, subtract 5K, subtract 5K. This gives us negative R greater than or equal to negative 5,500. And just what happened before, now that we multiply by a negative number, you end up with R is greater than or equal to 5,500. Just like we said when we estimated, right? That R is going to have to be between 5,500 and 4,500. Now, let's check the other one just to make sure that everything worked out. So what if we did it this way? Well, our two cases, once again, would be R minus 5. And I'm just going to write 5K. I'm sure y'all know what I'm talking about. Minus 500. And then we're going to have R is greater than or equal to, R minus 5K is greater than or equal to negative 500. Once again, remember you flip the sign and you make this negative. So if I'm adding 5K to both sides, I end up with R is less than or equal to 5,500. And of course, if I add 5K to both sides, in this case, I'll end up with R is greater than or equal to 4,500, which of course turns out to be the exact same thing as this. All right, I hope that video was helpful. I know it was long, but you are through chapter 1. I look forward to seeing you in the next video.